Hi again, everyone. We're going to pick up this question that we've been discussing about this rocket that's flying through the air. And so we had just found the vertex of that rocket, and then the next question was asking us for finding the time interval when the height of the rocket is greater than 150 meters. And so I already said in the end of the last video that we should sub in h equals 150. Then we want to get it equal to 0 and solve. And so go ahead and do that, and then check your answer with what I get. I'll give you one more hint before you do that. And that is, try to common factor the a value out. It's going to make you have much nicer numbers if that's possible. If you don't common factor it out, you just have to do the quadratic formula with some uglier numbers. So here's the solution for e. You can check your answer and make sure that you get the same thing before moving on here. We have the height being 150 that we've subbed in. We rearrange it so we get it equal to 0 by subtracting 150 from both sides. Then, as I mentioned, we can common factor negative 4.9. which gives us an a value of 1, a b value of negative 12, and a c value of 30. And that is unfactorable, unfortunately, so we have to use the quadratic formula. The quadratic formula, when I rearrange this and simplify it, gives me a value of t equals 8.45 or 3.55. You would have arrived at the same answer had you used an a value of negative 4.9, a b value of 58.8, and a c value of negative 147. Just would have been a little uglier as you went through it. So if we can common factor, we try to. And so just so you can see a couple of the things that tend to trip people up in the quadratic formula, it's negative 12, so the b value ends up being coming to a positive at the beginning. And then the negative 12 squared under the square root is positive 144, and we subtract 120 from that. Now what we arrive at is these two times that are not the zeros. That's the misconception some people have. Remember that we first subbed in the height as 150. So those 2 points occur when this height here is equal to 150. And so those are going to go right along that line right there. So we have the point 8.45 and 150 over here. And we have the point 3.55 and 150 over here. We've also already found the vertex, which is 6 and 179.4. And we know the y-intercept is 0, 3. We did that at the very beginning of the question. Because of symmetry, because this distance here is 6, then if we go 6 to the other side, what we can find is the same height of 3. The x value is 12, or the t value in this case is 12. So this is time in seconds, and this is height in meters. Part F says, how long does the rocket stay in the air for? And so I'm going to answer that below. Finding how long the rocket stays in the air for is very similar to what we did when we found the height of 150. In fact, it's even a little simpler, because in this case, h equals 0, so what we're finding is we're finding the zeros in this case, or the t-intercepts. And so again, we're going to use the quadratic formula, but we're first going to see, is that factorable, and see what we can solve there. So pause the video, it's going to jump to the answer here, and you can check that when you've done it yourself. It's worth noting here that we can't common factor and we can't factor that. That's pretty clear right out of the gate. As soon as we have a whole bunch of decimals and we can't common factor, we're going to say it's not factorable and we're going to have to use a quadratic formula. So your a value is negative 4.9, your b is 58.8, and your c is 3. Subbing those in the quadratic formula gives you answers of negative 0.05 seconds and 12.05 seconds. And so the question asked how long the rocket was in the air for. Since it starts at 0 seconds, it's going to hit the ground at 12.05 seconds, therefore it must be in the air for 12.05 seconds. So let's add that to the graph and finish that graph off. Now if you look at the graph, I've added this 12.05 and 0 point. I have not added the other 0, and the reason I haven't added that other 0 is because it starts at time equals 0. So this parabola only applies from a time equals 0 to a time equals 12.05. I don't go down below that. That doesn't make any sense. That wouldn't be included. Only the time that it actually flies are we including. And so hopefully your graph looks something like that. And let's go back now and look at the other questions that I said I'd give you solutions for. So the second example, which is the sum of the squares of two consecutive integers one, is one that you have to expand out, set it equal to 0, and keep in mind that it's a perfect square, so it's a squared plus 2ab plus b squared. So it expands out to x squared plus 2x plus 1. Then we subtract 181 from both sides to get it equal to 0, and we can common factor a 2 out of all those terms. We're left with x squared plus x minus 90 equals 0. We try to find two numbers that add to 1 multiplied to negative 90. And the trick I mentioned earlier was taking the square root of that 90. and that gives us 9.5 approximately. So the two numbers we're going to try that add to 1 are going to be 10 and negative 9, and in fact those multiply to negative 90. And then as we go ahead and we pull the x plus 10 and set it equal to 0 and the x minus 9 and set it equal to 0, we get x equals negative 10 and x equals 9. Now remember that the x plus 1 was the other term. So x plus 1 in this case, negative 10 plus 1 is negative 9. And x plus 1 in the other case is equal to 10. So again, just like we had in the last solution, we have two solutions. We have negative 10 and negative 9. That works. And we have 9 and positive 10. So even if you could have done that by guess and check, this is a useful method because we're not always going to have such small numbers that are very straightforward. So let's take this now and look at the next question. Let's solve this picking up at b plus 2l squared plus b squared equals 70 squared. So you can see when you square the b plus 2 squared, you get b squared plus 4b plus 4 because of the perfect square. And then you arrive at something where you have two b squareds. This would actually work out really nicely if you only had one b squared. It would actually be factorable. But as it stands, we go ahead and we start by common factoring out the 2, and we get b squared plus 2b minus 2,448. Find two numbers that add to 2 multiplied to negative 2,448. The trick I told you was to take the square root, and the square root is 49.5. Because those two numbers are 2 apart, we try some numbers just to multiply together to see if they give us 2,448 that are near 49.5. And in fact, none of them do. So unfortunately, you can't factor this any further, but you can use an a value of 1, a b value of 2, and a c value of negative 2,448 and the quadratic formula. So we're solving for the base in the quadratic formula. It's equal to the quadratic formula we're given with the a, b, and c value I just mentioned. And then when we simplify it, we should get 9,808 under the square root. To make this an exact answer, it doesn't ask for it exactly, but I'm going to solve it exactly and rounded. I'm going to common factor a 4 out of here, and that square root of 4 is going to give me a 2, which when I common factor the 2 out of the first two terms on the top here, I can cancel out the 2, and I'm left with negative 1 plus root 2,452, or negative 1 minus that. Well, I can't have a negative length, so this one doesn't make any sense. So now I go up here to my conclusion where I can say that b is therefore going to be 48.5, and the height is that plus 2. That's why I've added the 2 there. So you can see there I've added plus 2. And you get height is 50.5. Therefore, the base is 48.5 and the height is 50.5 centimeters. And that is the conclusion for that question. You can go back and check that by substituting those into the left and right side of that formula, b plus 2l squared plus b squared equals 70 squared. There's a lot to do there, and I hope that was helpful. If you have any questions, as always, reach out and ask for help.